Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and concepts of time, distance and speed. So let's start. Now while we talk about time, distance and speed, we see that there are three ingredients or there are three constituents which make up this chapter or which make up mechanics. So in short, we are talking about the motion of the body. So this motion may be either a linear motion or it may be a circular motion. Now when I say linear means a straight line motion, but when I use a word like circular, so circular represents a circle. So when there are two or more bodies either moving in a straight line or two or more bodies moving in a circular motion. Okay, so taking it forward, now we know that since there are three constituent elements which constitute this topic, so now if I write a formula, the formula is speed is equal to distance upon time. This is basically what the formula is. At the same time, I can also represent this as velocity is equal to displacement upon time. There is a small difference between speed and velocity, and the difference between speed and velocity is when we talk about speed, we refer to speed as a scalar entity. Now scalar means that the speed will always be represented by, there would be a measure of it. It will be represented by some numbers along with units. That is how we define broadly a scalar entity. But direction has no role to play when we talk about scalar entities. But when we talk about velocity, which incidentally is a vector entity, in that case, it is not only that we talk about the magnitude, which is the measure of the speed, we talk about the measure of the speed. Now, when we are measuring something, it always needs to have a, let's say, a number value and a unit associated with it. So in this case, it will be, let's say, meter per second or kilometer per hour or meter per minute or kilometer per minute, followed by the direction. So that is basically what the difference is. And generally when we represent scalar entities, we use the lowercase, and when we talk about vector entities, then we talk about uppercase. Time incidentally is represented in lowercase because time is a scalar entity. Displacement is a vector entity. Okay, taking this forward from here. So when I take it forward, using the concepts of ratio, proportion and variation is what we are going to focus in this session. So now when I use ratio, proportion and variation, starting off with the ratio, so can I say, when I'm talking about speed, distance and time, if I say that speed is directly proportional to distance, keeping time constant. So how do I understand this? So maybe I'll explain it to you in a few minutes, but first we will draw the proportionality angle, and then we'll talk about the variation and the ratio as well. Now this gives you a chance to go through my videos on ratio, proportions and variations, because when we talk about a chapter like time, distance and speed, or we talk about a chapter like time and work, they are quintessential. They are very, very important and they cannot be separated. They go hand in hand. Okay. Now at the same time, if I say speed is inversely proportional to time, keeping the distance constant, and the last comparison that I can draw here is distance is directly proportional to time, keeping speed constant. And then I can take this discussion to the next level. And the next level is, now when I say that the speed is directly proportional to the distance, all I need to understand here is keeping the time constant. So let us say that I have to go to a place, and that place, irrespective of the fact whether it is known to me, doesn't make any difference, but I'm supposed to meet a particular person at that place. And I know that this is, I need to meet this person, and meeting always, something which is very important for a meeting is the time of meeting. So which is why I kept the time taken to meet a person is constant. Okay, now in this case, if I increase the speed, Now, whether I increase the speed or I decrease the speed, in any case there is a change in speed, because change refers to either what? Increase or decrease. And a third case here is there may be no change at all. So when I am talking about no change, that means I am talking about this discussion only. But when there is a change, for example, if I increase the speed, so let us say if I increase the speed to a 2s, I mean, now increase the speed to a 2s means what? I, instead of let's say 60 km per hour, now I have increased it to 120 km per hour, keeping the time constant. Now time here is, let us say 1 hour. In 1 hour I have to reach a place, is what I am discussing. So now, so as I said that I will be taking it to a next level, is what I am discussing now. So let's say this is point A, this is point B, and this is point C. These are 3 points that I am discussing majorly. So in the first case, now what I am saying here is, let us say my initial speed, let me represent it by O. SO was 60 km per hour, right? And let's say now time here is 1 hour. So in a certain case now, and this is something that I am keeping it as constant. So what is the distance originally that I am supposed to travel? So we know that speed is distance upon time. So distance becomes speed into time. So I'll be traveling how many kilometers? I'll be traveling 60 kilometers. Now, since I'm keeping time as constant, so basically I'm comparing between the two. Between which two? I'm comparing between speed and distance. Okay. Now, if I increase my speed, that means there is a change in speed. So change could be, I hope when you go through my videos on ratio, proportions and percentages are equally important. Because all of these concepts in terms of percentages, averages, ratio, proportion, variation, mixtures and allegations, all these things would be quintessentially used. Okay, so now let's say if I increase my speed to 100 km per hour, now I know that the time taken here I have assumed that is constant. So how much time would I be taking now? I mean, how much time is nothing but I'll be taking 1 hour, because that is something that I have kept it as constant. Now in this case, what is the distance that I'm going to cover? And this is small s. And these O and F are capital, but please understand this is not capital S. I'm using it as small s. Okay, even this is small. Okay, so the distance finally that I would cover here is, I know that whether it is initial distance or final distance. So final distance will be final velocity into the final time. Now final time here is constant. So I'll be covering how many kilometers? I'll be covering 120 kilometers. Okay. From here, what is the analogy that I'm trying to establish? I'm trying to establish what? I'm trying to say that if the speed increases, the distance to travel, I mean the distance of travel also increases, keeping my time constant. So which is why what I was trying to put forth here is, speed is directly proportional to distance, keeping the time factor constant. Taking it further, now taking this as an example to extend this further, point number D. Any change in speed will be directly proportional to a change in distance, keeping time constant. You can use the same logic. And you can say here what? Keeping time constant. Now what is the change in speed? The change in speed is the final speed minus the original speed. So the changes could be absolute change, or the change here may be a percentage change, which is why I suggested please visit my videos on ratio, proportion, percentages, fractions, etc. That will give you a further insight on this. Okay, so now when I say change, and I'm talking about an absolute change, so SF, which is my final speed minus the original speed, is 60, right? At the same time, my final distance minus the original distance comes out to be how much? 60. So any change, so here it increased. Though I can take another example here, and I could have said that this I could have taken it as my original value, and then this I could have talked about the final values. For example, I could have started the discussion. As of now, the discussion was this way, starting from here to here, but I could have started my discussion from this point to this point, in which case, in the first case, the speed and the distance, both of them increase. because they're directly proportional to each other. In the second case, if these are my original values, they become my final values. So the decrease in speed will result into a lesser distance to be traveled, keeping the time taken to travel constant. This is what I was trying to explain. Okay, talking about point number. So somewhere you can note it down. When I'm talking about delta, delta refers to what? Change. And the change could be what? There are three cases for a change. So the change may be positive, there may be no change at all, and the change may be negative. Okay, talking about the next point. The next point here is we are saying that speed is inversely proportional to time, keeping the distance required to be traveled constant. So let us say that I'm supposed to go to a place and the place is 60 kilometers away from here. So let's say distance is equal to 60 kilometers and this is kept constant. Now if my speed, I'm taking my speed, let's say we take the same example here. If I take the speed originally as 60 km per hour, this is the original speed that I am taking. Now in this case, what is the original time that I would get to travel the same distance? So time taken to travel would be distance upon speed, which is 1 hour. Right? Now if I say that, okay, if I would have taken my speed to be 120 km per hour, in that case, how much time would I take? Would I take lesser time or more time? So when I have increased my speed and I know that I am supposed to travel the same distance, keeping all other parameters constant. All other parameters could be traffic conditions, could be my car not becoming defective on the way. I mean, there is no snag in the engine and so on. So keeping all other conditions constant is what we are talking about when we are talking about this chapter. Okay. So now in this case, the time taken would be what? Half an hour. So what is the relationship that we are establishing from here? For example, let me say from here to here, the speed increases, right? But when I go from here to here, the time decreases, which establishes what? Which establishes that speed is inversely proportional to time. And at the same time, I can establish, now there is a change. What is the change here? The change here is plus 60. But the change here is what? Half minus 1, which is minus half hour. So can I say the change in the speed will also be inversely proportional to the change in time, keeping the distance to be traveled as constant and keeping all other parameters constant. So when I say all other parameters constant, I'm basically referring to there is no other impediment. Now when I say impediment, I'm basically talking about no snag in the engine, I mean no disturbance, no natural calamity whatsoever, keeping all other parameters constant. The last but not the least, so this was point number B that I was discussing. I mean, you could have taken it the other way around also. I mean, if I would have started from 120 to 60, in that case my speed increases, but the time taken to travel the same distance increases, which also endorses that both of these are inversely proportional to each other. So not only their absolute values are inversely proportional, but the changes in values are also inversely proportional to each other. Last but not the least, so let me talk about the third case here. So A, B, C. So the third case here is, now we are comparing distance with time. So by now we know that the changes in the distance of travel will also be directly proportional to the change in the time taken to travel at the same speed, right? Okay. So now point number C, let me start it off taking the same example, and the same example here refers to basically, let me say that somebody has said, maybe my mother would have said that, you know, you will drive at an average speed of, let's say 60 km per hour, or your speed should remain the same. So there are two interpretations here. When I say that I'm keeping my speed constant, there are two interpretations here. When I say that something is being kept as a constant. Now constant means what? Unchanged. So either right from the start, I mean when you start from somewhere, you cannot start off with 60 km per hour. You have to start off with a lesser velocity. But the point to understand here is that the speed taken to travel the entire distance over the entire time should be kept as a constant, is what we are talking about. And we'll talk more about this when we talk about average speed, so which we'll be talking about in other videos. So keeping the speed of travel as constant now let's say that I am supposed to travel a distance of 60 kilometers. How much time will I take to travel this distance? So time, I know in any case, is distance upon speed, which is 1 hour. Now let me put this, the same discussion that we have done earlier, let me put this as original distance that I was supposed to travel and the original time that I was supposed to take to travel the same distance, this distance. Now finally, let me say that somebody tells me, hey, now you have to travel a distance of 160 kilometers, but you can't change your velocity. Now when you can't change something, that means it has to remain unchanged, which means you are keeping that thing as constant. Now in this case, how much time would you take? So you will say that time is nothing but 120 divided by 60 km per hour, 120 kilometers divided by 60 km per hour, which comes out to be 2 hours. Now here let us see, we changed the distance. So now I hope you are aware of the fact that if I increase the speed, if I increase the distance required to travel, it results into increment of time. So which means that distance is directly proportional to time, keeping the speed constant. Now when the distance increases, the time taken to travel keeping the speed constant also increases. And when I go the other way around, so in that case this also increases. When I go the other way around, this decreases, and the same thing I can say for this. When I go the other way around, if these were the set of my original values and these are the set of my final values, so there is a decrease in distance. If there is a decrease in distance, there would be lesser time also taken moving at the same speed. Finally, so from here you can talk about ratios. So from here, if I were to establish a relationship, let's say if I say final speed upon original speed, what is the ratio? So you will say 120 divided by 60, which comes out to be 2:1. Now what will be the ratio of their time? So the ratio of their time would be, so the ratio of the time is nothing but 1:1 only in this case. So you will say that the ratio of their time is nothing but 1:1, because why have you taken it as 1:1? Because time was kept constant. Now in this case, this ratio is equal to the ratio of their distances traveled, which is df by do. This is talking about case number A. Case B, and this is something which was kept constant. Now case B, you know that distance was kept constant, so you can now immediately start off with df is to do. F is final, O is original, is 1:1. Now in this case, what are the two remaining parameters that you're supposed to compare? One is speed and the other is time. So what is the ratio of the speeds that you have taken here? You have taken it as 2:1. But when you are taking the ratio of their time, you know that the ratio originally you are getting what? So can I just change this to, if this is 2 hours, in that case this will be taking 1 hour. So can I say this ratio will be nothing but TO is to TF. So originally, let's say if it was taking 2 hours, finally it is taking how much? 1 hour. Which proves what? Speed is inversely proportional to time. Part C, and this we are talking about ratios, though I have expressed it in terms of a fraction, but you have to understand this in terms of a ratio. Finally, now here we are talking about speed to be kept constant. So let's say if I am saying final speed is to original speed is equal to 1:1, and which is supposed to be kept constant. Right? Now in this case, what are you going to compare? You are going to compare the distance of travel and the time of travel. So in this case, final is, now 2:1 is what we are talking about, and same would be the ratio for the time also to be taken finally and originally, because distance is directly proportional to time, keeping speed constant. Here you will say that speed is inversely proportional to time, keeping distance constant, and here you would say that speed is directly proportional to distance, keeping time constant is what we have talked about. So in this video, we have majorly talked about how to apply the concepts of ratio, proportion and variation for a chapter like time, distance and speed at an elementary level. As we record more number of videos, the level would increase. If you feel that something very informative has been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do videos on some specific topics, do not hesitate and put it in the comment section. Thank you so much. Until next we meet, goodbye.